Hello, good day. I want us to look at a problem today, which involves the application of integration to calculate volume. So here's the question that I have. It says, make a neat sketch of the graph y is equal to 3x minus x squared. Show the strip used to calculate the volume if the area bounded by the graph and y is equal to 0 rotates about the x-axis. And then it says calculate the volume generated if the area described above rotates about the x-axis. So when we are solving these kind of problems, like the question directs, the very first thing would be to make a neat sketch or sketch that shows the area that will revolve, as in the question there, about the x-axis to generate that volume. So if we look at what we have there, we are given the function, or rather the graph of y is equal to 3x minus x squared. So I'd like to sketch this graph on a Cartesian plane. So if that is my y-axis and that is my x-axis, and I look at y is equal to 3x minus x squared, notice if y is equal to 0, then I have 3x minus x squared being equal to 0. Take out x there, you have x minus 3 is equal to 0. That means either x is equal to 0 or x is equal to 3. So I know this graph passes through the points x is equal to 0 and x is equal to 3, which if this is my origin and if this is the point 3 on the x-axis. Now the graph y is the function y is equal to 3x minus x squared. You can see that the coefficient of x squared there is negative. So therefore this graph, this parabola, will be facing downwards. So when we sketch this graph, it is going to look like that, where this is the point 3 and this is the origin where it is passing through. Now we are told that this area that we have is bounded by this curve y is equal to 3x minus x squared and y is equal to 0. So we know that y is equal to 0 along the x-axis, or x-axis is actually referred to as well as y is equal to 0. Now the area then that will be bounded by these conditions would be this particular area here. And as we know that this area, to calculate the volume, the representative strip here is perpendicular to the axis where you have got your limits, which is the x-axis. So if I put my strip right there, remember the representative strip which I am putting in black here is just a strip to represent the area that that we want to calculate, or that is rotating about the x-axis. So now that we have a sketch, a neat sketch of this graph and the conditions given to bound the area, we can now go ahead and calculate the volume. So the question says calculate the volume generated if the area described above rotates about the x-axis. So if it's rotating about the x-axis, that means I can calculate the volume Vx. Vx simply means that the area that I'm calculating, or the volume that I'm calculating, is rotating about the x-axis. And you can see that if this area is rotating about the x-axis, if it's rotating about the x-axis, it is going to form a solid of revolution. And this solid of revolution that is formed, we can only calculate that volume using what we call the disk method. Use the disk method. So the formula then to calculate volume rotating about the x-axis using the disk method is given by Vx is equal to pi into the integral from a to b, A and B being the limits on the x-axis, so that you can see here our area starts when x is 0 and it ends when x is equal to 3. And that is, of course, y squared to x, like that. Now we can put in all the necessary information into the formula. So that's integral from 0 to 3. Y squared, remember y is equal to 3x minus x squared. So this would be 3x minus x squared. And all that is squared. And we're integrating with respect to x there. Now, before we could integrate, we need to simplify the integrand there. And this, if we break the bracket here, if we break this bracket, in other words, square 3x minus x squared, we'll end up here with 9x squared minus 6x cubed plus x to the power 4, like that. And that is if we simplify that bracket. So now that we have simplified, we can now integrate. And if we integrate here, we have pi into integrate 9x squared. I'm going to get 3x cubed. Integrate there, that will be minus 6 over 4, which is 3 over 2 x to the power 4. And of course, plus here 1 over 5 x to the power 5. And we have our limits from 0 to 3. Now I have to put in the limits. Put the upper limit first. In other words, where there's x, I'm going to put 3, minus when you put the lower limit. Where there's x, you put what? 0. So you see this becomes 3 times 3 cubed minus 3 over 2 times 3 to the power 4 plus 1 over 5 times 3 to the power 5. Right? And of course, minus. If we put in x where there's 0, where there's x, this is going to be 0, 0, 0. So ultimately there it's minus 0. So now you can simplify this. This is going to be pi into, that is 3 by 3 to the power 4. 3 by 3 cubed, that is 81 minus 3 over 2 times 81 plus 1 over 5 times 243. 3 to the power 5 is 243. So we can simplify there. That becomes pi into, quick calculation, that gives us 81 over 10, and this would be units cubed. So that's the volume that we get. You can convert that to a 3 decimal place number. But basically, in a nutshell here, you see that for us to calculate the volume, the best way to go is number 1, to sketch. Let us visualize what the question is asking us. Let us show the area that we have and put the correct representative strip and identify the correct limits. And we have our limits. Then we pick up the right formula. In this case here, we see that the volume that is generated makes, we can only calculate that volume using the disk method. And then the rest is just the procedural work of integration. So that's how we can deal with this particular question. So now, if you are watching this channel right now, I would like you to, number 1, subscribe. Secondly, like and then make a comment so that we can be able to respond to your comments and give you more information as per your requests. Thank you.